now that is making a lot of money. If you think about what is the profit margin of that, that's a massive loss from a profit standpoint. But the reward in human life and moving forward that innovation edge and what it might mean if we can develop those products more economically is huge. So that means that staying at that cutting edge requires investment in the science to do the mRNA vaccine, to pull the right kind of cells out of that individual cancer. All of that happening here at Sloan Kettering is an example of where we are right at the cutting edge. We are also right at the facing a cliff of possibly losing that cutting edge for two reasons. One, we're gutting the NIH funding that underlies the science that makes all of this possible. That case that I described, that is not a money making in the short term opportunity. A lot of research funding is required to serve that one patient, patient number two, patient number three, to get to the point where maybe it becomes highly profitable in patient number 1,000. At the same time, China is really leaping ahead. While we are gutting funding, they're pouring funding in and starting to leap ahead in new ways. Washington is tracking China's growing leverage over APIs, manufacturing the components we need to make an antibiotic or a generic drug. I'm going to call that the low-tech side of the medical supply chain. We can make that stuff if we want to. We used to make it in New Jersey. Lots of folks can make that stuff, but the profit margins are really low and it's offshored to China. I'm going to set that aside and call that the low-tech side of the supply chain. What I find really interesting and not getting enough attention in Washington is the high-tech side, using biotechnology to develop new drugs. This is where China is leaping ahead. Some ways in which this is happening in China. China's combining AI, biotech, and robotics in ways that the US is not. They have firms in Shanghai and elsewhere that are basically a massive aircraft hangar full of cubicles in which each one is a robot with an AI model testing biological plates and generating data points that go into a massive database that can be used for drug development. This matters because the frontier edge of biotech and drug development is becoming a bit of a numbers game. There's a race underway to map the genomes of the species of the world. We've only begun to scratch the surface of the genomes that are out there. And what we're finding is that as we learn more about other species, that can convert into new and innovative drugs. One example is GLP-1, weight loss drugs. A lot of folks don't know that GLP-1 came from mapping the hormones of the Gila monster. So the Gila monster is a lizard that exists in the desert and has a venom that is very slow moving. And some of the elements of that slow acting venom have been pulled out and used to slow the absorption of insulin in the body. That's GLP-1. If China has warehouses full of AI-enabled robots that are doing gene sequencing and mapping around the clock, 24 hours a day, 7 days a week, they can do more of this mapping than we can, and then turn those data points into drug development. Beijing is also rolling out really smart, supportive policies for drug trials. In the United States, if you want to do a phase 1 trial, good luck. You better have money. I've talked to cancer scientists who are using family money to finance their own drug trials, and 99% of them fail in phase 1. So they will probably lose that funding. In China, they are now giving a $2.5 million no question asked grants for phase 1 drug trials, and failure is expected. That means the barriers, think about if you have to either beg, borrow, or steal $2.5 million to run the one trial of what you're developing in the lab, or if you can just roll them out and get grants to do so, who's going to be more cutting edge? Who's going to push the envelope? And which one is going to have, the most likely success? So where we are right now, just to wrap up, we are ahead of China by a couple of steps, but we are on track to fall behind. When I talk to heads of R&D for drug development in the United States who are tracking the China market really closely, they estimate that we have a 5 to 7 year window before China begins to surpass us. What that means is that instead of the rest of the world coming to the United States for innovative cancer treatment, we may be flying to Beijing. There are opportunities to work with China for drug development. they have some comparative advantages that we want access to, and we don't want to lose that. But we don't want to be dependent on China and innovative drugs the same way we are currently dependent on China for the components that we need to make amoxicillin. So happy to share more in the conversation, but I'll stop there for now.
Okay, thanks. Really, really fascinating stuff. We're going to turn next to Jimmy Goodrich, who is a senior advisor for technology analysis at RAND and a senior fellow for the University of California Institute on Global Conflict and Cooperation. He was previously vice president for global policy at the Semiconductor Industry Association. I think Jimmy's going to talk to us a little bit about US-China competition in semiconductors.
Well, great. All right. And pleasure to be here with many friends and new friends as well to talk about China's strategy and overall advancements in the semiconductor space. Semiconductors, I think, has already been a fairly well covered area of intense competition between the US and China. And so, what I'll just do is provide a quick overview and backdrop as to China's historical industrial policy towards integrated circuits and semiconductors, and then fast forward to where we are today, particularly as it revolves around AI. As Bill mentioned, and as Melanie have mentioned so far, AI is really important for different parts of the economy. One of the critical inputs to that, of course, is the computing stack and the silicon that enables that. So China, of course, for actually now decades, has strived to build a self-sufficient semiconductor ecosystem. Well before, U.S.-China tensions escalated, China had actually already in place the world's largest sovereign wealth fund for national semiconductor development, which was announced in 2014 as their National Integrated Circuits Development Fund. And that is now in its third phase, over 50 plus billion, now actually 75 billion if you count the third phase together, of combined government central equity that is being invested across their companies and their industries. Prior to that, China had also experimented with tax breaks, with top-down government industrial policy, with government-led R&D projects. And the common theme throughout all of those since the 90s really is when China started building up its domestic semiconductor ecosystem, has been capacity and capability enablement, however, still lagging at the leading edge in terms of technology. As one of the challenges in the semiconductor industry has always been, is that if you're innovating towards a stationary target, you're going to get surpassed when you get there by those that are already moving ahead of you. And that's been China's challenge to date, particularly around Moore's Law, as Moore's Law or different aspects of Moore's Law, whether it's in advanced packaging or thermal management, that have enabled the increase in computing power and the decrease in cost. That still provides challenge with a significant hurdle to be able to overcome. On top of that, as we all know, the semiconductor industry is incredibly globally interdependent with many different aspects of very high value add strategic technologies with a moat around them that are very difficult to re-innovate. Think photolithography, some of the equipment and materials, some of the advanced chip designs, some of the advanced firmware that chip companies use to be able to allow their developers to use their chips for their own systems. That is where there is still a significant difficulty for China in building a scale of an ecosystem that can fully replace Western semiconductor technology. So the common theme since the 1990s really has been that while China has invested in capacity, it has grown the share of its industry from a minuscule less than 1% of global semiconductor revenue to now over 10, 15% of global semiconductor revenue and semiconductor chip design. It's grown its share in global semiconductor manufacturing capacity from less than 5% to nearly 30% of global installed semiconductor capacity. It still is challenged at the leading edge in creating a self-sufficient semiconductor ecosystem, particularly in the upstream side for fabrication and materials. Um, it's not to say that China is less innovative than anyone else, but they're also not innovative than anyone else at the end of the day. And so the same challenges that Western companies have had to overcome in terms of bending the laws of physics for things like extreme ultraviolet lithography, or designing chips with over 100 billion transistors, or figuring out how to code firmware that thousands of different users and diverse range of applications are going to be able to use effortlessly turns out to be very difficult to do. particularly since 2020, in the escalation in U.S.-China tensions, as the U.S. imposed export controls and other aspects of technology restrictions, largely in response to increased Chinese aggression and its advanced military capabilities. China has also expanded and increased the pace of their localization drive. So while China's industrial policy in 2015 to 2020 was relatively targeted, but still significant, and those targeted areas, like in memory chip production and advanced logic chip production, China has expanded essentially to all aspects of the semiconductor supply chain. In fact, in the 15 five-year plan, now Xi Jinping in his recommendation wrote that China has to pursue extreme measures to innovate across all aspects of the supply chain in integrated circuits. And so this is really now the party is top-down mandating that the Chinese industry has to see tangible success in these choke point technologies over the next 5 years. So it's essentially the party is saying this is now make or break. And actually, China used and Xi Jinping used similar terminology when he imposed a political target of poverty alleviation in the 13th to 14th five-year plan. And so they're using the same political slogan and political campaign mobilization around this. The big question will be, is it going to work? Can political top-down motivation at the end of the day make scientists and engineers work better together to solve problems? There's no doubt that China is investing significantly. The scale in their investments are massive, but at the leading edge of technology, there still remains that gap. That doesn't mean, though, however, that China's investments in mature or foundational semiconductors don't pose strategic challenges for the US and its allies. In fact, they do. China has steadily grown its share in that space of semiconductors. That's going to and is already in many areas placing pricing pressure and commercial competitiveness challenges on Western or Taiwanese and Korean and European companies that simply cannot compete at that level of subsidization that Chinese companies have. And so whether it's in auto electronics, consumer electronics, or semiconductors for everything but the AI stack, essentially, China's making significant strides there. And that is an area where, we may come to a asymmetric codependence where the US and its allies in Taiwan and in the Netherlands may hold the leading edge advantage, whereas China may hold the strategic dominant advantage in foundational semiconductors as well. And so those are just a couple of points that I wanted to share this morning, tracing the history and kind of where China is today and the inflection point that their industrial policy has, particularly as Xi Jinping is imposing a stronger sense of urgency to his industry, even more so than before. So I think over the next 5 years, we're going to expect even a increased acceleration of their efforts. So back over to you, Ari.
Thank you, Jimmy. One thing I'm really struck by, and I think we're going to hear it even more in the next presentation, is just how all these technologies are interrelated and really build on each other. So next we have a discussion of quantum with Constanza Vidal Bustamente, who is a technology and national security fellow at the Center for a New American Security, where she leads the center's quantum technology policy portfolio. Prior to CNAS, she worked at the National Academy of Sciences. Constanza, thanks for joining.
Thank you, Ariadne. Thank you so much to the fellow panelists and everyone that joined today. I'm excited to bring some attention to quantum as well. I think it's definitely a more nascent technology than the ones we've heard from today, but definitely one that is gaining importance, and definitely lots of similar themes as well from what the other panelists have mentioned. So, and definitely a big priority technology for both countries, for both China and the United States. So to take a step back, just to kind of give you a sense that quantum technologies actually encompass a variety of different technologies. We think of them in three main buckets. So most people may have heard about quantum computing, and this is definitely the one that I would say has gained the most attention from the media, from policymakers, but also from the private sector. It's received the most investment. There are also a couple of other buckets of technology of quantum technologies that include sensing and communications. And both countries are interested in all three. I think at the top level, the US has an edge in computing and sensing, but China is rapidly making progress and catching up. And China is definitely the world leader in communications. So both countries have made a priority to make quantum a priority in their national strategies. China has certainly made it a priority in their 5-year plans, and they have been pouring substantial investments across R&D, enabling scientists to really have the resources they have to pursue cutting edge work in quantum. And this is a bit different from the United States. We've seen some strong regional clustering around areas in China like Hefei, Beijing, Shanghai, Shenzhen, some of the other or typical concentrations of technology development. And they also have, compared to the United States as well, access to advanced manufacturing that allows for that quick transition for breakthroughs from the lab to advanced technologies. In computing, so the United States still has a bit of an edge there. I think we've seen that the United States has pursuing different modalities for quantum computing, whereas China might be more focused on some, like superconducting quantum computing. But they do have consistent funding, and that is something that I think is different from the United States. There's no uncertainty on leading scientists having access to all the resources they need to continue pushing the technology. I think another difference there as well is that China focuses also on the kind of the supply chain, the enabling technologies that are ultimately the key to breakthroughs in the kind of integrated technologies like computing, sensing, and communications. So they focused a lot on photonics, on lasers, on cryogenic systems. These are critical to advance to make the quantum technologies actually useful and successful. And I think the United States has had more of a focus on the integrated technologies and perhaps supporting more of the companies and researchers that are kind of bringing those pieces together. But that has led also to a lot of weaknesses in our domestic supply chain since we haven't focused on those kind of not quantum per se technologies, but that are nevertheless critical to realizing quantum technologies in the real world. I think another trend that I've been focusing or that I've been tracking from China is that they're really pushing on their international engagement as well on quantum early on. I think I should have mentioned, for instance, for quantum computing and in particular, which is again the one that has gained the most attention, I think rightly so because of the threat to breaking public key cryptography, which is definitely a big national security priority that we should be paying attention to. Nevertheless, that threat is still a few years out. Expert estimates might put this at maybe 10 years out at kind of on an optimistic timeline. But despite that, the fact that we don't have those technologies readily available yet, some early prototypes are becoming like early systems for these technologies are becoming available. And I think China has been doing the work of early on to build those international partnerships such that they stand ready to then deploy once they have the more mature technologies ready to scale. And I think, some of that international engagement has been with, I guess, the usual suspects, some of the BRICS countries, some countries that are more aligned with China, and across the global south as well, and some South American countries like Brazil, in Mexico as well. But increasingly so, I think they're trying to engage with Europe as well, and some other countries that maybe you would think would immediately say no to Chinese engagement, but nevertheless, they're trying to build those connections and skirting perhaps some export control regulations as well by making some of these technologies available via the cloud such that they can start gaining engagement and China can promote this image of being the partner of choice for many countries. So I think that's definitely a trend that I've been watching with concern. I think especially as well as we enter a phase where multiple countries are vying for quantum leadership, global quantum leadership, including in Europe, that is increasingly as well asserting its technological sovereignty agenda. And concerningly to me, placing China and the US kind of as a similar level of threat where they want to stay ahead of both. But they're still engaging perhaps with both countries to some degree. And I think there's been less of a clear-cut preference for one over the other, which again, like at an international level and understanding the importance of having global markets for these technologies to scale is something that concerns me. So back to the United States, I guess we've had, just to close with some thoughts here, The United States has been funding quantum information science for decades, but it was back in the first Trump administration that quantum became a national security and economic security priority. The Congress and the executive branch worked together to establish this National Quantum Initiative that included a bill was passed in the Senate to send this up and provided very substantial investments to quantum technologies as increasingly becoming more mature and commercializable. And that, has fostered, it's led to close to a billion level investments in R&D. It supported the growing quantum industry in the United States, and the United States has the greatest concentration of quantum companies in the world. So those are all great things. Early on, there was a lot of focus on kind of the protect agenda to place export controls and research security measures around quantum. This was received broad bipartisan support. It was continued by the Biden administration, and actually the Biden administration was the one that released the export controls on quantum computing toward the end of 2024. So those are all kind of positive moves to support the quantum industry, and growing U.S. leadership in quantum. The problem is that currently, the National Quantum Initiative Act that I mentioned, some of the key R&D provisions there that really led to the substantial increase in investments that kind of increased fivefold relative to what we were spending before. Some of those key provisions expired in 2023, and that bill has not been reauthorized yet. Even though quantum garners a lot of bipartisan support, it hasn't really reached the high level of priority where Congress has actually passed a reauthorization of that bill. So that's something that concerns me, because that includes some of these funding streams have continued regardless of the reauthorization, but it creates a lot of uncertainty on some of the key pillars of quantum innovation, such as fundamental research and workforce development. And so in a climate where we have huge cuts to the federal budget, it's not a guarantee that these agencies will be able to continue to put the resources that they need toward quantum, and that's something I'm concerned about. On the supply chain side, as I mentioned earlier, the United States has not put as much attention on some of the enabling technologies that are critical to advance quantum devices, quantum computers, quantum sensors, and so on. So we have a pretty fragile supply chain in the country. We still rely on multiple inputs from outside the United States, some critical materials coming from China, included China, and many others in Europe and the rest of Asia as well. That requires, of course, like as with everything else on supply chain, substantial investments and the understanding of the importance of these subcomponent categories that may not be as sexy as quantum tech, but nevertheless are critical for that. And then finally, on the international front, like I said earlier, I think these trends of different regions of the world trying to assert their own leadership strategies in quantum, leading to fragmentation of those markets and perhaps less alignment of strategies there, both on the promote side and on the protect side, is something that I'm concerned about. And just finally, I think the United States still leads in many categories of quantum technologies, but it's definitely not something to take for granted. I think these rising trends are something that concerns me, and hopefully, we can actually leverage the bipartisan support that we have for quantum to actually move forward. But unless we actually pass those policies and make substantial investments, we can say, quantum has all the bipartisan support we want, but it doesn't help if it doesn't come with those concrete actions.
All right. Thank you, everybody. And just as a reminder, for people online, if you have questions, please put them in the chat function. So, I mean, one of the, all these technologies really fall into, a national security category. And, a lot of, they're all reliant on semiconductors in some way. And I know the US has tried in the past number of years to put an increasingly high wall on semiconductors and some of these technologies in terms of export controls and other things like that. How effective have we been in protecting our key technology And has that been successful? And is that the right path forward? I'm going to ask Jimmy, but then, the question, and then I'm going to open it up to some of the others.
Yeah, I mean, I think my current perspective is that overall semiconductors have been sort of a mixed bag in terms of their effectiveness. And that's partially because the United States has really kind of gone about it on a haphazard approach. Either not well coordinated with its allies that allows foreign often allied companies to just simply fill the void for exports from US companies that are restricted, or slow patchwork regulations that don't keep pace with the ability for China to work around regulations. So, for example, in many cases, it is entirely legal for a US company to export a restricted item to a company that is across the street from another company that they cannot ship to, simply because one is on a list and the other isn't. And even in some cases, they might share the same parent company and share the same personnel, share many other traits, but our export control regulations have not been updated to reflect that. I think rules like the affiliates rule, we're attempting to look at that. They wouldn't have fully addressed it, but now we're in this interesting paradigm with China where export controls are on the negotiating table over trade issues. And so, I don't think we expected to be, but here we are seeing export controls oftentimes perhaps negotiated away for something like soybean purchases. And so, really entering into a whole new era where export controls become now a tradable negotiating point of leverage between the US and China. Now, China, of course, is also trading some of its export controls that they've also established on rare earths in exchange for some of the US export controls. Not semiconductor specific yet, as the affiliates rule was not a semiconductor specific rule per se. But there is no doubt, in fact, the Wall Street Journal reported earlier today that in the leading edge of technology, export controls have created a buffer between the US and its allies and a little bit more breathing room than would have been otherwise. Had there been no export controls, China would have a fleet of extreme ultraviolet lithography machines and likely well beyond the 7 nanometer node at scale. China would likely already be having its memory chips embedded in Apple iPhones around the world, as the Wall Street Journal reported that on the eve of the US government entity listing of YMTC, they were close to supplying a major contract to Apple for their smartphone chips. And so, from if what I say is a mixed bag. Have they entirely halted China's semiconductor development? No, and one could argue that no export control ever will, as China is a formidable nation. But have they bought some time for the U.S. in advanced AI? Yes. Have they also led to displacement in the market for U.S. companies? Yes, at the same time. And Chinese companies continue to find workarounds to the export controls. I think one of the perennial challenges for our U.S. export control system is that we're just undecided as a nation as to whether or not we're committed to the issue. At the end of the day, export controls, to be effective, will impose economic harm on U.S. and its allies. And if we're not willing to impose that harm, they won't be effective. And so, in a sort of an attempt to find a balance or trade-off, whether it's negotiating with our allies that might take multiple years, or coming up with a narrower approach as opposed to a broader approach of restriction, at the end of the day, that leads to ineffective restrictions. And it may just be that as a nation, we're not willing to impose economic harm on ourselves for strategic national security gain the way that China has, particularly in the way that is uh, shut down some of its exports of rare earth, or it has made massive investments in its economy to boost its self-sufficiency and accelerate its own decoupling on a pace much faster than the US is decoupling from China. So one could argue, the cards are kind of in China's advantage where they're accelerating their decoupling. They are building their own strategic supply chains at a pace that requires an investment that is a form of pain on their economy much larger than the US is willing to sacrifice at this point.
Thank you. I mean, that is obviously one of the trade-offs between having a democracy and an authoritarian regime. They can impose as much pain as they would like to advance larger goals without having to face the electorate. Um, I think one of the other challenges that the US has faced is obviously China pumps massive, massive subsidies into its tech industries. Um, can the US compete against those billions of government funds? I know the US has the advantage of access to a robust capital market. Um, I'll just talk to Melanie for a moment. What are your thoughts about um, how can we compete against China's subsidies and investment in research, and what are other things the U.S. can do to maintain its lead?
I think I'll focus on biotech. I think we have to look at, again, the high tech side and the low tech side. If you look at the low tech side and the API supply chain, that's a question of profit margins. It's cheaper to make things in China instead of making them here when it comes to antibiotics. But that means that we're dependent on China for antibiotics and SSRIs and statins and other drugs that will be a big problem for the United States if China just cuts those off. That's a question of US national security. And do you want to let the market decide that we will only get statins and antibiotics that are made in China? Or for a national security reason, do we want to invest in some capacity in the United States that might not be the smartest economic decision, but from a security standpoint makes good sense? I think we should do that because we don't want to be in the same place in APIs where we are already right now in critical minerals. But that's just a decision of how much onshore capacity we want to have to make sure that that supply chain can't be used against us. And that's a decision about we have to put money into it if we don't want to just be a cog in the wheel of the Chinese model. That's the low tech side. For the high tech side, I don't think it's trying to outspin China. It's more trying to be a more refined, better version of how we do things and recognizing that if China is nipping at your heels, you don't have any maneuvering room to take some face plants and make bad policy decisions and still stay ahead. And I'll give two examples. We're ahead. We are at the point of being the only nation in the world that is developing mRNA vaccines for an individual against their own cancer because of the money that we pour into basic research. I think as an American, I appreciate that. I can't think of a better use of my tax dollars than making sure if I or any of my family members have a debilitating or life-ending disease, that the US government has been using my money to invest to ensure that we have the most path-breaking treatment and that it's here in the United States and I have access to that. That to me is the smartest spending we can do. But if we just stop spending that money, which is what we're doing right now, we cannot expect to maintain that edge. That won't be happening in the United States. At the same time, we aren't well, there are plenty of areas where we could be better organized. And we've had the luxury of being able to stumble forward a little bit with China staying well behind, and that era is over. And if we want to stay ahead, we have to look for areas where we can do a better job and not have big gaps in policy. One big one is drug trials. In the United States, if you are a patient battling cancer, you are not going to hear about the most innovative drug trials unless and until your doctor has tried all of the standard of care. And then your ability to access the most innovative ones might depend on who your doctor is. If you're at Sloan Kettering or if you're at MD Anderson, you may find out about some of these trials because of the personal networks of your specific doctor. And then you're going to be dependent on who your insurance company is to determine if you're able to pay for them. There's another model to do this. Why not have in the United States a centralized platform so that any patient at any time can say, I have disease X, doesn't have to be just cancer. What are the most innovative trials out there to be able to access that, to have that paid for? That right there would suddenly give pharma companies in the United States an entire new population for drug development that we currently don't have right here in the United States and have to go to China for. That would also give United States more power over patients, more power over their own cases and more information and ability if they want to try something innovative that they wouldn't have otherwise heard of, why not? I think that's a good way to have more data and more patient access. We have not done that, but we sure could. That's it for me.
Thank
Maybe just
you.
one other quick point there is that, on
Sure.
the capacity side, one thing we can do is also create, buffers around our own markets, working with allies to create sectional agreements that, for example, would say, all allies would agree to impose a certain tariff level on Chinese imports. Or, there could be essentially a quarantine where within certain allied zones, only different purchases of allied goods would be permitted for those strategic goods so that you would be competing on a level playing field on price. Otherwise, you're just simply going to be, at the end of the day, unable to compete against the subsidized margins that companies like BYD or SMIC might be able to provide.
Thank you. We have a couple questions in the chat, and I'm just reminding people, put it in the Q&A, not in the chat function. I shouldn't call it the chat. It's in the Q&A function. Um, Someone asked, can you, and I guess this is a bit directed at Bill, but anyone else can, I think we can discuss it more broadly, the concept of sovereign AI and its implications for the global South.
I'll defer to somebody else on that. I'm not familiar with the concept. It's not something I hear China talking a lot about. Um,
Okay,
Yeah, I mean,
Jimmy?
yeah, sure. Sovereign AI is essentially, different nation states trying to build their own large language models, or also inference or train some of their own large language models. And this is becoming quite popular amongst countries that don't necessarily want to be dependent on the US or China for their language models that may not reflect their own language and culture. Or it may just be countries are seeking, I think sovereign AI is now kind of like a big general term where if you're Guyana to Brunei and you have wealthy oil money and you want to spend some of it, well, you can build some data centers. It's not really sovereign AI because you're going to be hosting someone else's technology, but you have some skin in the game, so to speak, in the AI economy. And so I think there's really two flavors of sovereign AI. There's real sovereign AI, which is what you see like Singapore or France talking about, and then there's sort of just becoming part of the AI economy. And one of the big questions is with U.S. export controls is can the U.S. be competitive overseas and providing offerings? And one of the big answers to that is, well, can China produce enough chips to fill the void? Currently, the answer is no. Huawei, for example, is not able to produce enough chips to be able to let fill domestic demand, let alone exports. Um, and many Chinese companies themselves are going to offshore US cloud or hyperscalers with US chips to train and inference some of their own models. I think at the end of the day, there's always going to be dictators and one party rule states that want to use Chinese AI models that can conduct surveillance. And we probably don't want to win those markets. And so we should also question ourselves, what does it really mean to promote American values of AI if we're going to go help Kazakhstan build some sort of, population management system with large language models and AI? Should we just let China do that or should we have US companies do that? There still needs to be a conversation around what those American values would be in those overseas markets.
Absolutely. And you hit on a point really that ALI has focused on a lot, which are um, the importance certainly of developing American standards that reflect our values. Um, just to kind of pull back a little on the question of the global South, um, certainly I think as we move forward, there's going to be a much larger range of countries all anxious to get in on these technologies. Um, what is your thought of how, what the US should be exporting? Again, keeping in mind the security aspects of these technologies and the competition with China as well, and two sides of that coin. Constanza, I don't know if you have any thoughts on what the global market and competition for quantum is looking like.
Yeah, sure. So I think I mentioned some of this in my remarks as well. I think China has understood the importance of building that global market and building those relationships. I think especially as they understand that they are under attack and the US is pushing really hard in other technology fronts. to combat Chinese capabilities and be very strict with or increasingly ramping up measures on the protect side, on export controls, investment screenings, research security, and so on. So I think they've been trying to build those relationships, and I think especially as the United States starts to be there's a little bit more uncertainty on how much the countries around the world can rely on the United States as a partner of choice. They're entertaining, capabilities that China might be able to provide for them when they're not able to create a local ecosystem that's, robust, strong enough, or at the cutting edge like other greater powers. Um, so I worry about those trends. I think at the same time, we are seeing United States companies engaging with key allies in the Indo-Pacific, in Japan, in Australia, in Korea, as well as the UK and maybe a few other key countries in the European Union, to build those customer relations and create it. Actually, this starts at the R&D level as well. I mean, there's been a lot of engagement with these countries on the R&D side, kind of at the university level. These collaborations have existed for a long time. But I think increasingly, the quantum startups, and slightly bigger companies are trying to sell those systems to some of those countries that I mentioned. And we've seen some sales actually in Australia, in Japan, and Korea of some of these, mostly on the quantum computing side. So some of that exchange is happening. I think that's encouraging, and I think we should continue to build on those relationships. We've seen, I think this goes beyond as well, the commercial market and continuing to build those international relationships to align on export controls and research security measures, which is critical. And I think we've seen, like I mentioned before as well, it was a very interesting actually lead up process in determining the export controls that came out in the United States in 2024 on quantum computing. That was basically a number of countries organizing themselves outside of the Wassenaar Arrangement to agree on a list of controls for quantum computing and then individually adopt those controls on a country by country basis. There was a lot of concern there it wasn't so practical to use the Wassenaar Arrangement as a mechanism because of some concerns with Russia not following along with that. So they had to resort to this kind of unofficial approach, and it took a while, but it was successful in multiple countries then adopted the same controls, and that allows for multilateral coordination on that, and also excluding each other from those controls if the country has incorporated equivalent controls. So anyway, I think continued alignment like that will be important. I think a critical part there as a more nascent technology is that the technical thresholds that are set to determine which items should be controlled, those are kind of changing over time as these technologies mature. And so we basically rely on that continued engagement and alignment across these countries to continue maybe revising those systems, revising those restrictions to ensure that we continue to protect accordingly and kind of in lockstep there to be effective. And similar things apply to investment screenings and research security measures as well. But I guess broadly, I think definitely the international angle is a critical one as these technologies are trying to build their maturity and create that customer base. And one that I'm kind of tracking with a bit of concern. I think we are seeing partnerships still from the United States side, but there's also a lot of uncertainty that we hear from other countries. And again, like I mentioned earlier, Europe trying to ascertain or enhance their own technological sovereignty, rely less both on the United States and China. I worry about that fragmentation of markets there and fragmentation of strategy more broadly across kind of promote and protect measures.
Thank you. So one of the challenges is I think we do want to engage with China on some level. And I think I wanted to just ask you all about the importance of having, whether we can have mature dialogues with China on controls and standards on any of these technologies? To what extent should we be cooperating on any of these technologies versus protecting and limiting? And what are your thoughts on that? Melanie, you want to start, and anybody else can chime in.
Sure. I think the biotech sector is really unique and interesting in that, as somebody who works on China, it can be a little depressing these days because there's
Yes.
just no common interest to be found anywhere. And the reason I'm really intrigued by biotech is having less people in the United States and China die from disease is pretty much the only common interest I can come up with at the moment. I mean, as an American citizen, if China develops an innovative new drug that will treat my disease, I want it. Right? I mean, that's an area where we can talk great power competition, but if they come up with something that can cure me, I want it. And so there's a core critical interest there that we have personal and national interest in detangling from the real security concerns, such as I also don't want China to be able to develop a targeted drug that they can, spray something across DC and it only takes me down, right? I mean, there's definite security concerns, but also great opportunities as well. And so in this sector, it's worth doing the hard work to detangle that and figure out how do we work with China on drug development. They have a billion more people than we do. They're getting some of the diseases that we do at very high rates. That's a really big study population that we don't want to cut ourselves off from. How can we maintain access to that, but not build the same dependence on high-tech biotech that we have on the lower tech side? That's a solvable problem. It just requires some good policy solutions. One example would be, good data sharing regimes. One great idea, that we've thought about here at the Atlantic Council is, can we have a neutral third party in which we share some of the data that we're using for clinical trials without giving those core secrets to China? And China may want to share that in ways that they don't give patient data to the United States, but still enable some kind of collaboration on drug development. We need innovative solutions to be able to maintain the collaborative side without giving away the farm on the IP or taking risks with national security. But it's a needle we can thread, and for saving lives, I think it's worth it.
Couple more questions, and then I think we will wrap up. Jimmy, someone asked online about, from a security perspective, what's the pro and con of U.S. government direct investment in Intel?
Well, I mean, obviously, this is a debatable issue, but you know, what Intel wanted and needed, and they're quite open about it, is funding faster from the U.S. government. The CHIPS and Science Act was a historic development that, for the first time, enabled significant scale-up industrial policy for the U.S. to be competitive. But it did take a little bit of time for it to get up and running. About 2 years from when the bill was passed to when funding was actually started to trickle out. And then the funding that did trickle out was milestone based, meaning that companies would not be guaranteed the funds up front, and it was performance based. For companies that are struggling like Intel, then it would make it very difficult for them to get that funding. They need quickly to be able to re-energize their manufacturing and foundry operations. And so for Intel, I think it's definitely an advantage. However, for the US government, it's a larger risk as you're putting money faster into an organization that has not yet proven that it can meet its milestones. One could argue, though, the government doesn't have a choice. There are no other domestic competitors to TSMC other than Intel. To a lesser extent, maybe Samsung from South Korea, but the only homegrown option really is Intel. And so I think it really is a case by case, tool that should be used in some cases, where the market really is just not going to deliver the results you need. The U.S. government is using that for its rare earth mine investment from the Department of Defense because there was no market incentive to do so otherwise. So I think if it's done judiciously and carefully and selectively, it could be a tool that is useful, but it should not be something that we use sort of as a knee-jerk reaction for everything.
Thank you. So one last question. Obviously, on both AI and, well, really AI, quantum, and biotech. Obviously, there are other nefarious uses, Melanie, for biotech, as we discussed. Um, and it has, I think, also agriculture and military implications as well. Um, how is it going to be possible to work with China to develop any kind of safety or security kind of guardrails on these technologies? Or should the US just focus on working and developing those kinds of guardrails with allies moving forward?
Well, in the case of AI, that's pretty much the standard point of view. When you look at areas where we can cooperate beneficially to both sides' advantage, it's clearly safety. We're facing existential threats, in the worst case scenario. And that's all fine. I understand the need for that. What concerns me though is I'm not sure we have, as a country, a really complete understanding of what is happening in the world of AI in China. I mean, you've got a handful of Chinese capable analysts that are looking at what they're able to see through open sources. You've got the intelligence community doing what it can when it wants to understand, what's happening. No dialogue between the two, of course. But in terms of the big picture of what's happening in China, mostly what we see is enough to scare us, but not enough to understand really, what to do about it. So, I wouldn't want to leave, a seminar like this, close a seminar like this, where we're concerned with American leadership in technologies in general, not to mention AI, without stating that we're not really positioned now to understand what we're up against. And it doesn't have to be that way. China has a very clear understanding of what's happening in US technology for a lot of reasons. They're very good at ferreting out details that we don't do because of hubris. For many years, many decades, we were at the top. There was no need to develop the mechanisms to understand, what is happening, in adversary countries. So the thought I would want to leave with the group, is that, can't we do more along these lines to understand what we're up against? What I'm trying to say is good policy depends on good information, and I can't say we have that.
I mean, the US has the, I guess, advantage and disadvantage of just being a more open, transparent society. Um, and that comes with a lot of benefits and some challenges because China is not built that way. Um, Jimmy, any thoughts, Costanza, on whether we can work with China to build even kind of the broadest of guardrails on some of these issues?
I mean, I think in some areas, like in biosafety, and AI safety, there should be joint common interests, for example, to have a prohibition on the development of mirror life, which in Science magazine, scientists noted could pose an existential risk to humanity. And I think China shares a common goal of not eliminating humanity, hopefully, with the US, or setting guardrails for how U.S. and Chinese companies and global companies should use AI safely, perhaps to prevent, say, the spread of the weapons of mass destruction, or nuclear, biological, chemical warfare agents as well. In other sort of pure technology areas, I'm just simply less hopeful. I think if you just read the party rhetoric, clear, explicit goal to decouple from the United States as fast as possible, to build supply chains that we are dependent on, that China can wield against the United States. And so I think unless you have a change in direction from the top in China, from Xi Jinping, it's hard to justify really any form of technology cooperation in these strategic high-end areas, as unfortunately, whether we like it or not, Beijing does approach it from a zero-sum perspective.
Got it.
I think,
Okay.
oh,
Yeah, Costanza,
I
yeah.
chime in
You want to
quickly
make
on,
a
on quantum. I think
sure.
it's quite different from the other two in that the threats posed by quantum technologies are not kind of the kind that we see in biotech and AI, where we have a very concrete concerns about leaks of these technologies and so on. I think the greatest security threat that quantum technologies pose comes from quantum computing and the idea that once we reach large enough uh, capable enough systems in quantum computing, they will be able to run this algorithm that can break our public key cryptography that safeguards most of our digital systems in the US and around the world. So the antidote to that is to transition to new encryption systems that are resistant to these quantum threats, or so-called post-quantum cryptography. So that's something that the United States has been actually leading the charge on through NIST. There was this competition that started back in 2016 on designing these new algorithms that, starting this international system where basically different experts tested different new algorithms and test them for whether they will be resistant to these computers or not. And then now NIST released their first 3 standards in 2024, and now the process is toward adopting those systems. And that's more of a domestic issue of the US government aligning their public and private sector to adopt these systems. And it will take several years and billions of dollars to get there. The idea is to do this ahead of us actually having a computer that is capable to break that encryption, which is kind of placed around 2035 or so on. So that is a more of a domestic role and definitely a very difficult one. The international aspect of that is to also get other countries to adopt those standards to ensure interoperability of these systems. But that's kind of the level of the threat that we're facing. I think going back from the quantum domain, so less something, I think here it's less something to coordinate so much with China around like safety measures and more about getting the world to adopt these new systems, these new encryption algorithms, so that we can maintain secure communications and interoperability across them. But I would say more on
Okay.
US China. Oh, sorry. I guess
Yeah, I
yeah,
think
I'll
we
give it back to
thank
you
you.
if we're
I
short
think
of time.
I think we need to wrap up. Thank you all. I think this has been really interesting and, really fascinating. We obviously have our work cut out for us in all these areas. I want to really thank all of you and all our participants for joining. And as I said, the ALI is going to be doing additional work on U.S. technology leadership and economic security, and look forward to getting your further input as we work on that. So thank you all. Thank you, everybody online. Enjoy the rest of the day.
Thank you.